Hey geometry class, this is the last section that we're going to have on ways we can prove triangles congruent. And the last two ways are through something called angle side angle and angle angle side. So very similar to how we've been using side 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 and side angle side. We have these two last congruent theorems. So let's move on. So here's the congruence postulate for angle side angle. It says if two angles and the included side of a triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So what you're going to be showing congruent in this case is similar to the side angle side. You had the included angle to be shown congruent in each triangle. Well, we have an included side. So the side that needs to be shown congruent in each triangle needs to be in between the two angles that are being shown congruent in each triangle. Okay, so let's fill out this statement here. Angle B needs to be congruent to angle E. BC needs to be congruent to EF. And then angle C needs to be congruent to angle F. And then that makes triangle ABC congruent to triangle DEF. All right. So we'll use this here in a little bit in a proof and in examples like I've shown you before, deciding whether enough information is given to prove two triangles congruent. Here is the other theorem or postulate called angle angle side. So if two angles and a non-included side of a triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. So here we have, going in order around counterclockwise here, motion, we have angle B, go to the next angle, angle C, and then side AC. And those are congruent to our E, then angle F, and then side DF. So all of those need to be shown congruent in order to show your two triangles are congruent with angle side or angle angle side. All right, so let's fill this statement out. So angle B needs to be congruent to angle E. C needs angle F to be congruent. Then AC is congruent to DF. Then we can say that triangle ABC is congruent to DEF. So there's the angle angle side. Okay, so just like examples we've done before in other congruence postulates or theorems that we've been using, we're going to decide whether enough information is given to prove the triangles are congruent using angle side angle or angle angle side congruence postulates and theorems. So let's look at this first one. We have two corresponding angles here being shown congruent and then another two here. So by the third angles theorem, we should know both of these are congruent, or even by the vertical angle congruence theorem, we know that these are congruent. No sides are being shown congruent, but all three angles are congruent. This right here is not one of our congruence theorems, so there is not enough information. Okay. Now let's look at this next one. We have two corresponding angles being shown congruent, and then two corresponding sides being shown congruent. And then we can also say by vertical angle congruence theorem, that these two angles right here are congruent. So let's go in order. Angle, side, angle. These two triangles are congruent. There we go. Now let's look at this last one. We have two separate triangles here. We have a corresponding angles being shown congruent here, and then two corresponding angles shown congruent here, and then a side. So that follows the postulate or congruence theorem of angle, side, angle, because we go in order: angle, side, angle. All three of those are being shown congruent to corresponding angles and sides in the other triangle. So there is enough information to show these are congruent, and by angle, angle, side, these triangles are congruent. All right, so now let's look at using these two theorems or postulates in proofs. On this first one, I have write a proof using angle, side, angle congruence postulate. So we know we're going to be using angle, side, angle in this one. Let's look at our given information first. So this angle right here, the PRQ, it's given to us, and it's already marked on our figure that they are congruent to SR or SQR. Okay. And we should also know that since both triangles have a common side, that it's congruent to itself. And then by this, knowing that these two lines right here, I'm going to extend them, are parallel to each other, that PQ and RS are parallel. I'm going to extend this out. That line right here is our transversal going through those two parallel lines. So we can show two other angles are congruent with this, knowing that PQ and RS are parallel. And it's these two angles right here. This angle is congruent to this one because they are alternate interior angles. Okay, so let's just make those statements in our proof. So statements and reasons. Number one, use the given information. Oops. All right, now that we've got the given information down, let's go in the order that I already stated before. We know that their common segment or common side is congruent. So we're going to name RQ is congruent to RQ, or RQ is congruent to QR actually. And that is the reflexive property. Now, statement 3, we're going to say that the angle that I marked here in red, or these angles are congruent to each other. And I already stated it's because of the alternate interior angles theorem. So those angle names, we're going to name them ERN. Or no, not ERN, sorry, that's my next proof. So angle PQR is congruent to SRQ. And then we are going to say by alternate interior angles theorem. All right, let's move this up a little bit. Okay, the last statement on here is number 4. Because we have shown and are given enough information now that we have an angle, 2 corresponding angles, a corresponding side, and another 2 corresponding angles being shown congruent in each of our triangles, then by angle, side, angle, these 2 triangles are congruent. So label or name the 2 triangles that we're proving congruent, the PQR and the SRQ. SRQ. These 2 triangles are congruent by angle, side, angle is what we have just shown. Okay, let's do one more proof. In this one, we're going to be using the angle side congruence postulate in order to prove these 2 triangles congruent. So let's get started on that. First of all, we are already given that these 2 angles are congruent to each other, and we know their common side is congruent. And then it also states in the given information that RN bisects this angle right here. So that angle is this one right here, ERV. This angle right here is bisected by this RN, meaning it splits it in half into 2 congruent parts. So we know that this right here is congruent to this right here. So let's make those 3 statements. And reasons. Okay, 1, name the given. And then the other part of the given, RN bisects angle ERV. Now the next statement, exactly what I stated before, we can go ahead and show that the 2 angles I just marked are congruent to each other. And the names of those are ERN and VRN. And the reason we know that those are congruent to each other is because of the definition of angle bisector. And then the next statement we need to show is that the side in common is congruent. So name RN is congruent to RN. And that is our reflexive property being used. Now, the last statement that we need to make is that these 2 triangles are congruent because we have just shown by angle, side that these 2 triangles are congruent. So statement 4, triangle ENR is congruent to triangle VNR by angle, side. And that is it for these 2 proofs that I've just shown you. Okay, now let's look at something else real quick before I let you go. So far we have learned several congruence postulates, and they're just different combinations of statements like angle, side, angle, or side, angle, side, things like that, or side, side, side. Those are 4 that we've studied. There are other combinations of those letters that we could look at, something like angle. But angle is not going to be one of our congruence postulates. And this is the reason why. And it's because two angles do not have to be the same size at all in order for them to have the same, or all three angles congruent to each other. So, for example, this right here, triangle ABC is just a scaled down version of the DEF, but they all the angles in here are congruent to each other. So angle ACE, let's call it a equilateral or equal angular triangle here. All of these are congruent to each other, but the triangles are not congruent. Okay, let's look at another one. And here's the reason why you are not going to be using the side-side angle or the angle-angle-side, as I've told you before, the donkey postulate. And that is because of this right here. This triangle right here is not congruent to this triangle right here, even though that we have two corresponding angles being shown congruent, two corresponding sides being shown congruent, and then a third side being shown congruent. This one right here is the same length as this one over here, and these two triangles are not congruent because this side right here is not congruent to this side here. Okay, so that is the reason why you're not going to be using those last two things as congruence postulates, because they do not show two triangles congruent to each other. Okay, so that is all I have for you in this lesson, and hopefully you understood everything, and I will see you all in class. Goodbye, everybody.